Hello everybody, this lesson is on exponents, which is also part of Unit 6.4 called expressions. Here's an idea. Exponents make writing math simpler by replacing repeated multiplication. Now that's a lot in that just one sentence, so let's take a look at an example. So here's an example right here. And by the way, this dot that's in the air, that's not a decimal point. That's a multiplication sign. This is a time sign. So this is 5 times 5 times 5 times 5. And so this is repeated multiplication. And what we can do with this is replace it with something simpler so that we don't have to write all these 5s. And so we could just say that this is equal to 5 to the 4th power. Okay? And we're going to look at another example later on of this. All right? And one thing that you'll notice is exponents grow incredibly quick. Meaning that if you took this and did this with your calculator, you would get a fairly big number rather quickly. So I encourage you to try that. If you were to do 5 times 5 times 5 times 5, take a look at what number you get for that. Let's take a look at another example. When we are multiplying several of the same factors together, you can use an exponent to rewrite the expression. Okay, that's a lot of stuff in that one sentence. So let's take a look at an example. Okay, so here you have 3 of these 2's. Okay, and these are the same factors. That's a 2, that's a 2, and that's also 2. So these are the same factors. Now, even if you don't know what factors mean, don't worry about it. So here's the thing. Here I am multiplying 2 times 2 times 2, and I can rewrite this expression to make it 2 to the 3rd power. Okay, so that's 2 to the 3rd power. Now, there's some other special words that you should memorize. So for example, you see this big number right here? That big number, we're going to call that the base. Okay, and that tiny number that's in the air, that is the exponent. Okay, now one way to remember the base is that the base, like in softball or baseball or kickball, the base is usually on the bottom. Okay, and just like here, this 2 is in the bottom while the 3 is up in the air. So that's the base, and just like in softball, baseball, and kickball, that the bottom is also the base right there. Now, we also need to know how to read this. So this 2 and 3 right here, we read it as 2 to the 3rd power. So that's another thing that we want to try to memorize. Or we can say 2 to the power of 3. And notice that we're using power, okay? So you can also think of exponents as powers. Now what we don't want to say is we do not want to say 2 times 3. So we want to summarize a few things here. Multiplication is repeated addition. Okay? Here we have a bunch of 2's that we're adding. 2 plus 2 plus 2 plus 2 plus 2. That is 2 times 5. But when we're talking about exponents, we're talking about multiplication. So 2 times 2 times 2 times 2 times 2, that is the same thing as 2 to the 5th power. So with exponents, think multiplication. A lot of people get confused. When we're talking about exponents, we are talking about just multiplication. We're not talking about addition. So that's another reminder there. Okay. For the math problem that we had students investigate, let me just go ahead and read this problem. It says here, genie's offer. After opening an ancient bottle you find on the beach, a genie appears. In payment for his freedom, he gives you a choice of either 50,000 gold coins or 1 magical coin. So there's a choice that needs to be made between one or another thing. The magic coin will turn into 2 gold coins on the first day. 1 coin becomes 2. Interesting. The 2 coins will turn into 4 coins total at the end of 2 days. So now 2 is going to become 4 at the end of the second day. By the end of the third day, there will be 8 gold coins total. So this pattern is repeating. And Jeannie explains that the magic coins will continue this pattern of doubling each day for 1 moon cycle, 28 days. So there's some doubling happening every single day. And the questions to think about as students are working on the math problems we gave them is, how does the number of gold coins grow each day? How many gold coins would you have on the third day? And how can we write expressions to show the pattern of how the number of coins is growing? Okay, so it's not incredibly important to memorize the problem right here or memorize the questions, because you can always go back and see it. All right, so just another thing to keep in mind. So like on page 6 right here is everything that we talked about. And page 7, you have access to this as well. There's page 8, there's Jeannie's problem. And then now when you get to page 9, this is where students have to fill in the table. And a couple key things to keep in mind. When we talk about expanded form, now, what do y'all know about the word expanded? So when we think of expanding, we mean stretching out, okay? Now, for example, let's say you have a balloon, and you take that balloon and you start breathing air into it. You'll notice that the balloon gets bigger and bigger and bigger, and that is called expansion. So I want you to think of expanded form as something that gets bigger and bigger and bigger, or stretching. Think of expansion as stretching. And you can see right here for sure that as we keep on writing more of these, you can see how stretchy it becomes, how it expands or stretches. Okay, now when we talk about exponent form or exponential form, that is where we are writing the exponents or the powers. Those little tiny numbers are your exponents or powers. And when we talk about simplified form, we are talking about writing something simple, which here is just the number. So like, hey, if you go from here to here to here, first of all, this is equal to that, which is equal to that. But simplified form, look how simple simplified form is, okay? So that's how you remember these words. That's how you remember what expanded form is, exponential form is, simplified form is, okay? And then you have to write here whether it's better than 50,000 coins. So like, for example, is 8 coins better than 50,000 coins? The answer is no. I would rather have 50,000 coins than 8 coins. All right, so, and then students are going to work on expanded form, exponential form, and simplified form, which is just like number 9. And then 11 is a comparison where you predict something, and then you do some math. You take a look at expanded form and simplified form. You can write over here, here, and here, and here, and here, and you can test whether these two are the same. All right, that is the assignment. Take care. Have a great day.